So today first we want to finish another topic related to data, that is arrays. Okay, so after arrays we need to do methods, so then structured programming is over. Okay, right, so let's move on to arrays. Right, so what is an array? An array is a type of variable. So usually in a variable you can keep only one value at a time. For example, when you say int x, so you can keep only one value at a time. At a different time, yes, maybe x equal x plus 1 or whatever. But arrays can be used to keep multiple values at a time. Right? Keep multiple values. How do you keep multiple values in a single variable? So when you create an array, you can assign different values to different indices. 0th index, first index, and so on. So that means just one variable, but multiple values, and those values can be accessed using the index. That is the idea behind arrays. So not only in Java, in almost all the languages, we have a concept called array, or maybe some with some other word, we have that concept. Okay. Right. So remember, arrays are objects, so that you will better understand when we do the object-oriented programming. Arrays are objects. An array index always start with 0 and then 1, 2, 3, 4, and so on. So in Java, array is always index start with 0, 1, 2, 3, 4, and so on. And also when you create a Java array, you must specify the data type. So once you specify the data type, your array can have only that data type or compatible types. Right? So in some other languages, especially languages like Python, where you can keep different type of data. But in Java, you specify the type and only that type can be kept in that particular array. Okay. Can we store image in an array? So no. Image you can't keep in an array because array can keep any primitive type or any object. Okay. Of course, indirectly you can keep, but built in, there is no support for pictures. Okay. Right. So that is a basic idea about arrays. Okay. So array can be 1 dimension, a 2 dimension, a 3 dimension, and so on. Okay. So we'll first use 1D arrays. So then we'll move on to 2D and 3D as well. Right. So how do you use an array? So let's start with, let's first use 1D arrays. Okay. So you can declare an array. Okay. So then you can create an array. You can assign values or reassign or modify values of the array. You can retrieve the values, individual values of a specific element or many or all elements. Okay, retrieve means read. So those are different things you can do with arrays. Okay, so don't worry, we'll look at some all of those things. Okay, right. So this is how you create a Java array, one-dimensional array. So remember, when you create an array, you must specify the data type, whether it's int, double, float, boolean, char, or later you will learn we can create array of objects as well. But forget about the array of objects. For the time being, you must specify the data type and then square brackets and then your variable name. So then you can create that array. So this is the declaration and this is you create array variable, new, the data type, square bracket, you must give the size of your array. So you can't create array without giving the size in Java. You must always give the size, whether it's 5 or 2 or. So 10 means basically 0 to 9. Right? 0, 1, 2, 9. Index. Of course, then you can keep whatever value you want. Okay. Or you can combine these two lines. And say int x equal new int or int or float or double, whatever. So once you create your array, either this way or that way, you can assign values to individual elements. So we call them individual elements, zeroth element, first element, second element, and so on. And of course, you can read the value to another variable, print it, and so on. So those are the things we do with arrays. Okay, so it's a single dimension array. Right, so let's do it as a practical thing. So I will be using IntelliJ. Okay. Right. So I have a project. I will create a new Java class. I'll call it array demo. So I will have my main method psvm public static void main. So I'll create an array. Okay, so let's create int array. Int square bracket start was say a. I will create the array also in the same line, new int. Now you must give the size. Let's say size 5. So this is how you create an array in a single line. Now this is array size 5. That means you have valid integers from 0 to 4. So how do you set value? You can set values individual like 0th element. So it can be any integer now, say 10. Maybe it's first element. You can assign it in whatever the order you want. Say 20 and so on. So if you have not assigned a value, right? So still the value is there, that the default value of the data type. Now I have assigned 0th and first element. So therefore I have set the 0th and first element value 0, 1, 2, 3, 4. Now this is 10, this is 20. But these elements still I have not set, but those are initially 0 because the default data type, default value for int is 0. If it is float or double, 0.0. If it is Boolean, false. Default value is false. And if it is star, there's a special character and so on. So therefore, don't think that these are empty. Those are having 0 because integer default type is 0. Okay, so let's print and see. S out, say A0. And let's print A1 also. And remember, we have not set the A2, but A2 has a value. A2 will be 0. Okay, because when you create an array, individual elements are given default values of that data type. So obviously this is 20 and this is 10. Okay. Right, so let's run and see. Run. Right, you can see 10, 20, 0. So the second element is 0. Not only second element, third element is also 0. Right, fourth element is also 0. Okay. Right, so the next thing is if you try to access element beyond the range, you will get a runtime error. For example, 0, 1, 2 is okay. Right? Even 3 and 4 is okay because this is size 5. But you can't access something called A5. There's nothing called A5 in this. So maximum you can go is A4. You can see there's a warning also, but if you run it, you will get an array index out of bound exception. Right? So it's a very famous error, array index out of bound exception. It's a runtime exception. Okay, runtime exception. So therefore we will comment this, but just remember if you try to access a value out of the range, it will result in a runtime error, not compile time error. When you run only, you will see the error. Okay. So if you need the fifth element, maybe you can increase this to 6. So 6 means 0 to 5. Okay. Right. So that is how you work with array. And also at any time you can reassign value. For example, now I can say again A1 is 90. So then this point onwards, A1 is 9. It's no longer 20. Individual elements can be reassigned. Okay. Now it is 90. I just commented this line because it gives you a runtime error. Okay. Now you can see it's 90. So individual elements can have different values at different times. Okay. Right. So that is how you create an array. So of course, if you want, now you can't assign something like 90.5. Why? Because what we have created is an int array. 90.7 or 90.5 is not a valid integer. So therefore, this is a compiler, not a runtime error. You can see conversion from double to int is not possible. Okay. But if you create a double array, of course, you can assign individual elements as integers because integers can be converted to double. Okay. Right. So any questions? Right. Now, if you want to assign values at the array creation time, there's another way of creating this array rather than this. Okay. So that is very easy, but that is when you want to assign values at the same times. Okay. Approach to say I want to create an array with the values also. You can do like this. Say int, let's call this B array. Within curly brackets, you give your values. Say 20, 45, 60, 30, and so on. You can give whatever the values you want and whatever number of values as well. Now, this is also int array, one-dimensional array. So this is the 0th element, first element, second element, third element. Now you must not give size here. Size is implicitly taken now. Okay. So again, if I want, if I type is B0. So B0 will be 20. 20. And B1 will be 45 and so on. Okay. Let's see. Right. So that is another way of creating array. Right. So next thing is at any time, if you want to find the length of an array, it doesn't matter whether you create like this. So that there's a property of, remember, arrays are objects. When you create an array, it's object. Okay. So that is why you use the new keyword here. Here also it's an object. Now, if you want to find length of array, there's a property called length. Right. A dot length. So that will give you the length of the array. Length means what is your size. In this case, of course, the size is 5. What about the B array? B array's length will be 1, 2, 3, 4. Okay, so let's run it and see. So let's make this B. Right. So this is 5. This is size is 4. That is how you read the size of the array. Okay. Yes, you don't have enough type, so just try to do the basic things only. Okay, so you don't need to type each and every thing. Just type the basic thing only. Okay. Yes, I know that you don't have enough time, but try to do as much as possible. Don't try to do everything. Right? Maybe just create an array and assign a value and so on. Okay, because otherwise we are running out of time because your exams are in January. Okay. So that is why we are doing it faster. Okay. And also you have the recordings and so on. Okay. Right. So therefore, try to do as much as possible. Yes, I know that you will not be able to type each and every line in this particular time slot. Okay. Right. So try to do as much as possible. And also, if you are using something like IntelliJ or something, of course, you can type quickly as well because you get uh, the help from the ID. Okay. Right. So, so that is how you get the size of the array using the length property. Okay. Length property. Right. So the next thing is you must know how to iterate an array. Iterate means go, so rather than accessing this like this, sometimes we want to access from zeroth element to the last element, right? In a loop. Okay. So there are two ways you can access or iterate an array. The first approach is uh, using normal loop. Maybe you can use while loop, do while loop, for loop. I told you do while is very rarely used anyway. So the most convenient approach is for loop. Okay. So this is my array. Okay, let's create another array also because we have created only int array. So let's create array double array. Say double C. Okay, I will create the array in a simple manner. Say 12.6, 8.98, 6.656. Let's have one more. 60, let's have minus value also minus 5.65. So this should become a, okay, and semicolon. So I am getting error. Okay, this must be array. My square bracket must be there. That is error. Right. So now I have created an array of double. Now I want to iterate this, not just access using index. Okay. So this is the first approach. Use normal loop. Let's use a normal for loop. For, let's say, iteration variable, let's call it I, int I equals 0. You start with 0 because this is the 0th element. You do this as long as I is less than 1, sorry, 0, 1, 2, 3. That means less than 4. Less than 4. Okay. So size is 4. Less than 4 means 0, 1, 2, 3. 0, 1, 2, 3. And every time I want to increment it by 1. So now maybe I can print it. Say C, its ith index. I will be 0 initially, then 1, 2, and 3, and so on. So let's use print, not println. And then we'll print a space also so that next time it will print to the next after a space. Okay. Otherwise, it will take a lot of vertical space. Right. So then initially it will print C0, then C1, C0 and space, C1 and space, C2 and space, C3 and space, and done. Because after 3, it is 4, 4 is not less than 4. You will get out of the loop. So basically this will print 12.6, 8.8, 6.56, and minus 5.65. Okay. So let's run it. 12.6 and blah, blah, blah. So this space is because I have kept a space. I just wanted to print it in the same line. That is why I use print rather than println. Okay. So at the end, I will have blank println so that my next content will be forced to the next line. So this is one way of iterating. And rather than hard coding this, if you want, you can use c.length. That is the best practice. Because if you change the number of elements, then automatically your for loop is again iterating from 0th element to the last element. So use these features as much as possible. So then your code is very reusable, maintainable, robust. Okay. And this approach is very flexible because you can iterate from right hand end to the left hand end, maybe you need to start with length value and decrement. Okay, so this approach is very flexible. Or you want to just access zeroth element, second element, third, fourth element, and so then you can say I equal I plus 2. Okay, so this approach is very flexible. But there's another way of iterating array, because most of the time we iterate from zeroth element to the last element one by one, like this. So therefore, they have introduced something called alternative for loop. Sometimes we call it array and collection friendly for loop. So when you use array or collection friendly for loop, the for loop is much compact, but there's a limitation that for loop always iterate from left hand to the right hand. You don't have the flexibility. Okay. Right. So how do you write array friendly for loop? Let's use the same array. And it's very easy. This is how you do it. Say for first give the data type of the individual element. So in my case, it is double. Double. Then give a variable name. You can give whatever the variable name you want. Okay. So I'll call it X colon your array name. In my case, array name is C. Okay. Now this will iterate your C array from zeroth element to last element. First time your X variable will be having 12.6, next time 8.8, next time 6.56, and the last time minus 5.65, and then iteration will over. That is why you need to give the data type, because this variable will have the indeed zeroth elements, first element, and so on. Now it's super simple actually. And now if you want, you can just print X. Okay, let's say print and space. And at the end, we'll have blank println line just to force it to the next line. Now this will give you the same output. But you can see this for loop is little bit things to type, but this for loop is very easily you can write. So therefore, when you iterate array from left to right, usually software programmers like this particular for loop, array friendly for loop. Let's try it and see. You can see we get the same output, but with very little work. Okay. Only thing is you can't use this kind of array to iterate from right to left or skip elements and go to the next elements and so on. Okay. Right. So that is how you iterate an array. Either you use this approach, or even you can use while loop, or use this compact for loop, which is specifically to iterate arrays. Okay. Right. Any questions? So that's it about one-dimensional arrays. Okay, one-dimensional arrays. I'll just rename this as 1D array, because then we can go to another code for the 2D arrays. Refactor, rename file, call it 1D array demo for this 1D array demo. Right. Because I'll create the other class as 2D array demo. Okay. And same output. Right. So now we move on to the two-dimensional arrays. So for that, let's create another class. 2D array demo. Okay. So let's have the PSVM tab. Right. So what is a two-dimensional array? Two-dimensional array is something like this. Where you have now two indexes, row index 0, 1, 2, 3, and column index again 0, 1, 2, and so on. An individual element is this is called 0, 0. This is 0, 1, 0, 2. First you refer to the row index, then you refer to the column index. This is 1, 0, 1, 1, 1, 2, and so on. Okay. So this is if you again you need to give the data type. Only that data type for compatible types data can be kept in a two-dimensional array. Okay. Right. So let's create a 2D array. Let's create a 2D int array. Int. So now you need to give square bracket twice, saying that it is 2D array. Okay. So then I will say A equal new int. Again, you must give your square bracket twice and give the size. First, you give the number of rows. I will say 3 rows. Number of columns, I will say maybe 4 columns. Okay. That is 3 by 4 array. 3 by 4 array. Okay. So 3 by 4 array means 3 rows. 4 columns. Something like this. 0, 1, 2, 0, 1, 2, 3. Okay. And initially all the elements will be having 0 because this is an int array. But you can assign values and then retrieve values as well. Now if I print what is say A0, 0, so that is 0, 0 element, it will be 0 because initialized with default value. Okay, so that will be 0 because I have not assigned a value. Of course, if you want, you can assign values. Say 0th row, first element. Sorry, 0th row, 0th element. Now it will be having say 25. I will assign one more value. Say 0th row, first element. Say 50. Now if you print 0, 0 element, it is no longer 0, it is 25. Okay, so this is a practical topic. Okay. That is how you work with two-dimensional array. Again, you can't specify values which are not compatible with the data type. For example, you can't say 15.9, that will give you compile error. And also if you refer to an index, which is not a valid one, you will get array index out of bound runtime error. Okay. For example, the biggest here I can go for 2, 0, 2, 1, 2, 2, 2, 3. But there's nothing called 2, 4. 2, 4, 1, 4, 2, 5, or 3, 0. There's nothing called 3, 0. Okay. So if you try to research, try to access like that, say 3, 0. Okay, let's do it again. 0, 0. Say this is 0, 1. 0, 1 will be 15. Okay. Nice. If I try to access something like say 0, 4, there's nothing called 0, 4. And you will get array index out of bound exception. Same error. Okay. Array index out of bound exception. When you run the last line, that is line number 9, you can see array index out of bound line 9. So therefore I come in that line. Okay. Because I don't want to get errors. So again, you can't access out of bound values. Okay. Right. So again, if you want to assign values at the array creation time rather than assigning like this later, again, you have that second approach 2, which is much convenient. Approach 2. So that is you create like this. Say let's create an int array. Int say b equal. This is how you create. So first have that curly bracket. So that is your main array. So then each row you need separate curly bracket. Say I need 3 rows. 3 rows separated by comma. And now you can give your individual rows. So this is the zeroth row, first row, second row. So zeroth row has 10, 20, let's assume, okay, 30. Say second row has, sorry, zeroth row, first row, 40, 50, 60, and maybe my second row, that is 0 first second, 70, 80, 90. Let's assume, okay. This is the second approach. This is the second approach. Now again, if I want, I can access 0, 0 element and so on. Again, you can't access invalid values. Then you will get array index out of bound, etc. Of course, 0, 0 will be 10. 10. Let's run it. Is 10. Okay. So that is very convenient when you want to assign values at the array. Again, don't use size because size is calculated by having your lengths and uh, columns values. Okay. So you can't specify. Okay. Right. So that is how you create 2D arrays like this approach, or straight away assigning values like this. So next thing is, how do you iterate? Again, you can use the normal for loop or while loop or whatever, or you can use array friendly for loop. Okay, array friendly for loop. So let's use normal for loop to iterate, say B array. Okay, B array. Iterate approach 1, then we'll do iterate approach 2. Right. So in normal for loop, it's little bit more coding, by the way. You need to go for nested for loop, something like this. Okay. And again for loop. So outer for loop will go from 0th row, first row. It goes from row to row. For each row, this for loop will go from column to column, element to element. Okay. So therefore I'll say for int, because index is always integer. I say I equals 0. I is less than, I can use the length property here. Okay. Length property here. So let's say b dot length, because that is better rather than hard code. So length will give you, in two-dimensional array, length will give you number of rows. That is very important. In one-dimensional array, how many elements? In two-dimensional array, length will give you number of rows. Okay. So let's have another value here. Say 40. Okay. Let's say 40 here. Then 50 here, 60, 70, and 80. And let's have 90, 100, 110. I just make it a little bit bigger. 120. So 20. Let's make it 110. Okay. Still, of course, this is 0. This is 10. Right. So now this length is number of rows. In this case, number of rows are 3. First row, second row, third row. Number of rows is 3. 0th row, first row, second row. So this length will be basically 3. And of course, you need to say I plus plus. And this for loop, I will iterate for individual elements like this. And it has always 4 here. So therefore, I'll say int. I will use a different variable j. Again, start with 0. Now, again, if you want, you can hard code, but the better approach is you can use j is less than, okay, my array is b, it's I throws length. This is the standard way rather than hard coding. Okay, my b arrays I throw its length j must be less than that. Okay. Why I'm getting error? B is an array. B is ith row. J is less than B. Let's say J plus plus
So
also.
increment, right?
What is that error? Yeah, that is now fixed, I think. Okay, right. So now let's print it S out. Now I will print my B array is ith row index, jth index. I is the row index, j is the column index. Okay, so this is my B array. It's ith index, jth index. Right? And since I want to print this in same line, I will just concatenate with a space. Okay, concatenate with the space. So this will go through full iteration for first row, 0th row, then the first row, second row, third row. And when you print one particular row, because I just like to print like this, I will have S out here, just to force the second row into the next line. That is just to force the second row into the next line, third row into the next line. Okay. Right. So now let's run and see. Okay. It's giving me error. Okay, that is suggestion only. Okay. It says use a enhanced for loop. Enhanced for loop means other array friendly for loop. Yeah, I know that, but let's use it in the normal for loop. Okay. So this means individual rows length. This is number of rows. Okay. Let's run it and see. Right. So I think I have used println. Yes. So let's make it print. Okay. Make it a little bit nice. Okay, now you can see 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So we iterated, this one is iterating the rows. For each row, this for loop is iterating column. Okay, column or the individual elements. So either you need to hard code here, but this is better because then if I change the number of columns, rows, still I don't need to come to this loop. That is how the code should be. Code must not be come and change all the time, right? So it must be flexible. Your code must be flexible as much as possible, right? So that is the first approach. Of course, the second approach is much compact, okay, much easier because then we in second approach we will use array friendly for loop. Okay, we will do this. Let's have S out here just to take it to the next line. And now I will show you how to use the array friendly for loop. It's super easy. Say for, again you need two for loops because it's a two-dimensional array. Okay, right. So the first one, I will iterate my array row-wise. So therefore, each row will be a one-dimensional array. One-dimensional array because each row is a one-dimensional array. So therefore, I will say int array. Let's call this x. Okay, colon. My array is b. My array name is b. Okay. So that means each time I get a 1D array because I am iterating row. Each row is a one-dimensional int array. Now this array will iterate this particular one-dimensional array. So therefore individual element is int. I'll call it y colon. Now I am iterating x array, which is a one-dimensional array. Now I can simply print my y value. I will print a space also. I'll do print statement so that it prints in the same line. But after full iteration of a row, I will force it to go to the next line. And at the end also, I will just force it to go into the next line. So you can see this one is little bit more work, but this one is much compact. But this for loop or nested for loop does the same thing as this with less effort. But this is always iterating from 0 to the last row and each row 0 to the last column, last element. Okay. So it's very important that you take this as 1D array and then you iterate this array, then individual elements are int variables. And you basically iterate your B array. Okay, so let's run it and see. Right. You must get the same identical result. So this is from normal for loop. This is using the array friendly for loop. Right. Any questions? So in all the languages, you have array friendly for loop. In almost all the languages, you have arrays. And this is how it works. Whether it's C, C++, C sharp. Okay. Right. Right. So the next thing is, if you want, you can create racked arrays. Racked arrays. Racked array means now what we create. So in this two-dimensional array, something like this. Every row has same number of columns. But if you want, if there's a very specific, of course, most of the time it will be something like rectangular shape. But there can be rare situations you want to create array like this. Maybe first row you need 3 elements. Second row maybe 2 elements. Maybe third row 4 elements. Maybe that is your requirement. So then you call it racked array. Of course, that is also two-dimensional array. So if you want, you can create like this. Okay. And again, if you want, you can iterate also. Same way. Same way. Okay. Right. So let's see how to create a racked array. So the easiest way to create a racked array is second approach. Like this. Other approach also work. So therefore, I'll create racked array using second approach because that is easy approach. This is called racked array. Approach 2. I will first do approach 2 because approach 2 is easier. Just give me 1 minute. Okay, so let's continue. So I will use this approach, okay, because that is easy approach. Right. So I'll call this C array. Say I have only 3 elements here. Maybe 4 elements here. Say 40, 50, 60, 70. Maybe only 2 elements here. It's up to you to decide, okay, depending on your requirements. So this is a racked array. This one has 3 elements, this one has 4 elements, this one has 2 elements, and so on. Even maybe one row has 1 element. Right. So now again you can refer to the individual elements. Say C00 will be 10. Let's run it and see. Is it 10? Yes, it is 10. Now how do you iterate this? So this is a racked array. 3 elements, 3 element row, 4 element row, 2 element row, and so on. Again, you can use this for loop or this for loop. Both the for loops work. So let's use the first approach. And then we'll iterate using another approach as well. So that the beauty is this, whether it's racked array, still we can use it. Especially if you use length property. Length property. So now this is a for loop. I can use the same way in this. That is fine. because this index has only scope within this for loop. So therefore, this I is no longer available, visible to here. Or you can just use different variable, but no need. Right. So now it is not B, it is C. So C dot length means number of rows. Of course, here number of rows is 3. So then for each row, its length. So of course, for different rows, its length is different. Here 3, here 4, here 2. That is why we refer to the length. CI length. Then we print C arrays ith row, jth column. And of course, this printed length, take it to the next line. And this is just to give an additional line. Right? So this will print something like 10, 20, 30, 40, 50, 60, 70, 80, 90. Using the normal for loop. Let's run it and see. Can see? Or you can use the second approach. Second approach is even easier. Okay. This approach, I will copy paste this code. You don't need to do any change at all. Okay. Only thing is now your array is C array. You take it to X, then X is take to Y. Okay. So then you just print the Y value. Okay. So make sure that this is C. So now if I run it, I will get the same output again. Using the array friendly for loop. You can see this is from normal for loop. And this is from array friendly for loop. This is from normal for loop. This is from the previous S out from the id element, 0, element. Right. So you can see that even with when your array is a ragged array, still you can iterate using the normal for loop or array friendly for loop. But you need to use 2 for loop, nested for loops. Okay. So these are some serious programming. Okay. Right. So that is I created the array, ragged array in this particular manner. Okay. If you want, you can create a ragged array using this particular approach as well. But the way we create the array is slightly different now. Look at how I do it. Right. Right. Ragged array approach 1. I use approach 1 because approach 1 is a little bit lengthy. I just do it second. So this is how you do it. Say I want to create an int array 2D. I'll call it D equal new int. Now you give the number of rows, say 3, but don't give the number of columns. Just keep it open. Right? Give the number of rows, but don't give the number of columns because for each row, we are going to create different number of rows. Sorry, number of columns. That is why I just keep it open. You can keep that open. Okay? You can keep that open. Now what you do is you need to create each and every row separately. Say int 0th row. Sorry. D. Its 0th row is new int. This is something like array of array. Okay. New int. Let's create the same array like this. Okay. 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. Therefore, this is size 3. Then this is size 4. And this is my first row. And this is my second row. Let's make it 2 elements. Yes, 2 elements. So now we have created a ragged array. First row 3 elements, second row 4 elements, sorry, 0th row 3 elements, first row 4 elements, second row 2 elements. Now you can assign the values separately. Okay, like Now you have created the array. Say D0, 0, it is 10, and so on. Okay, now of course you need to assign separate. Let me assign all the values so that we get the identical array. That is my first 0, 1, 0, 2, 10, 20, 30. First row, 0, 1, 2, 3, 40, 50, 60, 70, and maybe my last row, second row, 0 and 1, maybe 80 and 90. Right, so now I should have the same array like as this. Okay, but I created using little bit without assigning the values first. Okay, so therefore you need to go for this approach. Right, so now if I want, I can iterate also. I will only use the second approach because of course first approach also you can use. Right, you can use whatever the approach. Okay, just to show that it can be iterated as well. But this time my array is D. Right? Array is D. So I get the identical output for the third time. You can see 10, 20, 30. This is my second approach. I created the array 40, 50, 60, 70, 89. And again, if you try to access, now this first row has 3 elements. Zeroth element has, zeroth row has 3 elements. First row has 4 elements. Second row has 2 elements. If you try to access something like this, you will get array index out of bound exception. Obviously, there's nothing called 2, 3 because my third row has only 2 elements, 0, 1. So there's not even like this. So you will get a array index out of bound exception for this line 71. You can see line 71. So therefore, comment it because you will get array index out of bounds exception. Okay. Of course, you can iterate using our normal for loop as well, though it takes a little bit lengthy codes. So if you copy paste this and change this to D, still it will work. Okay. Right. So any questions about arrays? So we are done. So 1D array, 2D array. If you want to extend this to 3D arrays, say have in like this and again square bracket and give the number of third dimension. So it is a 3-dimensional thing. So then first index, second index, third index. And you can extend it to any dimension as well. 4 dimension, 5 dimension, 6 dimension. But very rarely we go for 3 dimension. Most of the time 2 dimension is enough. But in some cases like data analysis, data mining, we heavily use 3-dimensional arrays as well. Okay, fine. So that's it about arrays. That's it about arrays. So details are in your note as well. Okay, so if you have downloaded array note previously, make sure you download it again because I did some changes before the class and I just did some minor changes to make it a little bit more descriptive. Okay, right. Right. That's it about arrays. Okay, right. So now we move on to methods. Okay, methods. There's a question, if we get error output in the middle of the outputs, do we get next outputs after the error output? No. If it is a compile error, anyway, it won't even run. If it is a runtime error, once you get the error, runtime error, that is the end of the execution. So it will not execute beyond that. Okay. So that is the answer for that. Okay. Right. So now we move on to our final topic in structured programming. Final topic. So far we have done variables, arrays, which are related to data. Then from processing side, we have done operators, control structures. So third topic related to processing is methods. Okay, so this is data and this is process. So this is structured programming. Okay, that is the big picture. Right, methods. So then our next topic is object-oriented programming. Okay. Right. So what is a method? So when we do processing, sometimes we need to do same thing over and over. Maybe this screen also there's a validation. The other screen also the same validation is there. Okay. So here also we get a database connection. For some other operation also you need to get the database connection. So when you do same thing over and over, if you keep writing the same code again and again, that is waste of your time. And also, if you want to change that function, you sometimes you need to go 3, 4, 5 places and change that also. But if you put it into a method, okay, so then you can call that method many times. Then you need to write less code. And also, if you want to do some change to that functionality, you have one place to go and change. You don't need to go and change it in 4, 5, 6 places. So therefore, method is very handy. If you do use it properly, your code is more compact. You need to do a little bit less coding, and also maintenance is easier. Maintaining the code, because when you keep, sometimes you need to change the code and so on. And sometimes you can reuse that method for future functionalities. Okay. And also when you solve big problem, complicated software, we can break it into smaller and smaller part, all modules, and that functionality into even smaller part. So that help tackle complex problem solving. So rather than you concentrate on the big problem solving, now you concentrate on those small things. So then when you put it together, you have solved the big problem. So that is another use. So it effectively helps you concentrate on one particular part of the problem. So that is another advantage of using methods. Okay, so many advantages. So don't overuse it, but when you use it in a proper way, your code is much readable, maintainable code. Right, so this is the structure of a Java method. Sometimes we call these functions, for example, some languages like JavaScript, we call them functions, but in Java, we call them methods. So when we do object-oriented programming, you will again see these methods, okay, as behaviors, but this is structured programming. So when you do structured programming, this is the structure. Use the static keyword. If you have a return type for the method, you can use it like int, double, float, and so on. Then the method name, then parameter list, data type, parameter name, comma, data type, parameter name, data type, parameter name. Then your method body, you do some processing. And if you want, you can return a value. But if you return a value, you must specify the data type here. If you don't return a value, you can say here void. So then don't return. If you say void, don't return. If you say in double float, make sure you return data value of that type or compatible type. Okay. But method name is a must. It's a must. Parameters are optional. Return type is optional, or you must say void. If you say void, you can't have return statement. If you say data type, you must have a return statement, and it must return a value of that type. Okay. Now, for the time being, always use static keyword. But when you do object-oriented programming, you will learn how to write methods without the static keyword. Okay. But for the time being, just use the static keyword for each and every method. Actually, main method is a special method. It's also method. You can see we have been writing our code in main method. So only speciality is when you run a class, by default, the main method is called. So therefore, main method is your starting point for your class if you have a main method. So therefore, when you write other methods, we can call those methods from the main method. Okay. So this is an example of a use of methods. So we have written some methods, foo method, bar method. Sometimes you might be wonder why do we use word foo, bar, and bars? So these are just programmers conventions, right? So just like variables, we use x, y, z. So x, y, z means no special meaning. It's not amount. It is not age. Just we play around with variables. Similarly, when we just play around with methods without any special meaning, programmers use these words foo, bar, bars. Just a convention, right? So that is part of our software developers culture. We just call, just like we call variables x, y, z, we call methods foo, bar, and bars. Okay. Right. Anyway, if you want, you can just use x, y, z as well. Okay, or anything you like. So always your main method is the one that is automatically getting called. So therefore, make sure you call other methods from your main method. Maybe you call foo method, and foo method is called bar method. So that means foo method, main method is calling foo method is calling bar method. When the bar method return, you call the bars method and it will return. So make sure you have written these methods. Otherwise, there will be errors saying there's no such method, compile errors. Right? It's like a chain. You give the control to that method, it is executed and it is returned. Then you are again in your foo method, then you call the bars method, again you come back. And maybe bar method can call another method. Then it will come to here, then come here. So just you must visualize how it is done. Okay. Right. So let's do an example. I delete this because I copied it. I'll call this method demo. Right. I will have the main method because I need a starting point. PSVM. Right. So let's say I have a method called foo. Void, I will say void. Okay. Void foo. Static void foo. Void means no return value. No parameter also. Just S out, same foo. I'll have another method called bar. It's very important that you understand the concept, okay? Don't be hurried to understand concepts. Bar. Maybe here I will call the foo method. So maybe I'll say up here foo call the bar method. That is how the method chain happens. Maybe I have another one, bars. Maybe when foo method returns, of course, foo call the bar as well. I call the bars method. Now what will be the output? So main method, so this I'm in the main method, I will say is out. Main start, main end, just to keep track of the method calls. Here I say foo start, foo ends. And bar start and bar end. Of course, bar is not calling anything. And bar start, bar end. Right, what will the output when you run this program? So first output will be main start. Then you are going to the foo. So then foo start. Then you are going to the bar. Then bar start. Then bar ends. Then you are coming back to the foo method. So then foo ends. So then you are coming back here. Then you call the bars. So the output will be bar start, bar end, and you are coming back to here and then main end. So that is your output. Okay. So you must know exactly what happens. So this is the output. And it's a very good practice to do a debug and see. Put up a debug point, click on that line, main first line, then say debug. Then you can see exactly how things. So this is something you must be doing. Right now we are in this line. Still this line is not executed. So then I will say step over. Then I will say step into the foo method. Step in. Last time we did not use the step in. Now you can say step into the foo method. Okay. Now we are in the foo method. That is how the actual execution is happening. So then you can say step into the bar method. I'm step over the bar, again step over bar. You can see the output also. Foo started, bar starts, bar ends. Now we are going back to the foo, right? Foo, because foo called the bar. Now you are getting out of the foo back to the main. You are back in the main. Now after foo is called, now it is called bars. Now it's a step in. Now bar start, bars end. Now you are back in the main. And then you will print main end because there's no other thing. Okay. So likewise, you must experience this and see what is happening. Okay, what is happening. Right. So that is how it works. Now, so far we have not used any parameters. We are not returning anything. So simply just calling a method, and that method just does something. Of course, in this case, it is just printing something. Now let's see how to use. Now you must have idea about how the methods are getting called. If you want, you can again call foo method. That is fine. That is fine. Okay. If you want again, you can call the foo method and see what happens. Again, it is going. So same method can be called many times. Same method can be called for many other methods. Method can call many other methods. Okay. But it must make sense. Okay. This is just for your information. That is why I took the method name also as foo bar, like XYZ. Okay. Right. So let's write a little bit more practical code now. Okay. So I'll say new Java class. I'll call it math demo. Okay. Again, I will create a main method PSVM. Okay. So there I will create a method called add static, and it returns. It is not return anything. It is void, and I'll call it add. And let's say I need two integers to add. If you send me two integers, I will add and print the result. Say int. You can give any name like even xy, int y, and those are the parameters. So my method can have access to these parameters. So I will add those two numbers and assign to a variable. So this is called local variable. Say t equal x plus y. And I will print it because I have access to the parameters. I will say total is t. Now this method use two parameters. You can have any number of parameters. Your parameters can have different data type. Make sure you send correct arguments or compatible arguments. So for example, when you call add method, this is how you call them. Make sure you give two integers so which are compatible to integers. Say 10, 20. Right? So don't worry about this x bar that is given from the tool, not create a code. Okay. I just disable it, otherwise you get confused. Right, so now the output will be what? 30. Because I call the add method with 10 and 20. X will be 10, 20 will be, Y will be 20. So therefore it will be 30 is assigned to T and you print T. Okay, so let's run it and see. So the output is total is 30. The total is 30. Right, so this method use parameters. Now, when the parameter says integer, you can't say something like 20.6 because 20.6 is not compatible to integer. Then you will get a compile error. Program won't run. Giving a compiler and stop. You can see 316, third line. It says can't convert double to int. So therefore, make sure you are sending only compatible. These are called arguments. These are called parameters. If you have two parameters, two arguments of compatible type. Okay. Right. So let's try another method, but let's make sure that this method return a value also. So it has two parameters and return value. Say return is int. You take two and let's call this sub or subtract. Again, we have the local variable. You can use the same name again because this local variable is visible only from this point to this curly bracket. So therefore, same variable name can be reused in different methods because those are local variables. Or you can use a different variable. Okay. I'll call it sub S. Say difference is. Okay, let's say we don't print it. We don't print it, we just return it because remember now we have return value, return data type, it is no longer void like this. Say return S. Okay, return S. Now of course, when you call, you must assign it to a variable. Of course, if you want, you can say sub, say 50 and 20, but then the return value is lost. That return value is lost. You can see this is a warning. This is not error. Because if you want, you can run it, but the return value is not, you are not assigning it to assigning it. We got. You can see still the total is 30. You are returning a value, but no, this made method you are not getting it. So therefore, when you return something, make sure you assign it to a variable. Say we are returning int, so therefore let's assign it to a variable. Say R, and maybe you can print it. And difference is say R. Now if you, this method return the value and you print it. So the difference will be 30. Difference is 30. Because 50 minus 20 is 30, or let's say 50 minus 10. So then difference will be 40. Now it is 40. So now we are using parameters and also we are using return values. If you are returning a value like this, make sure you assign it to a variable. If you don't return anything, just call it. Okay. So those are very important concepts. Right? Any questions related to methods so far? And all the methods for the time being, make sure you use the static keyword. Okay. That you will understand when we do the object-oriented why we just kept it static. In structured programming methods are always we use the static method, okay? Static keyword for each and every method. Right. So now I want to explain what is mean by local variable and what is mean by global variables. Actually, we have already used local variables, so these are local variables. Local variables means variables declared inside a method. And those variables are only available within from this line onwards till the end of the method. Okay. But if you declare a variable outside a method, like inside the class somewhere here, we call them global variable. Global variable. So let me assign a variable here, and this will be a global variable. Static, always use static for the time being. Static, I will call it, say G, int G equal 10. So this is a global variable. Of course, you can give whatever name you want. So this is a global variable. So this is available to any method, including the main method, because it's a global. It's not inside a method. Okay, inside. So now any of these methods can refer to that global variable. And also if you want, you can change the global variable. And if you change, other method calls will see the different new value. Okay, so therefore let me create a method called foo, void foo. I can refer to global variables, say G's. So if I call foo at the end, and it will print the value of foo, sorry, value of G, because G is a global variable. Right, foo method, I want to make it static, otherwise it will give you errors. Right, so now the last print output will be G is 10, because I'm referring to the global variable in my method. Right, so not only that, if you want, you can change it. Say G++. You can change global variables. Okay. Now, if you want, you can again print G is, okay. So now G is 11. You can change global variables. And not only that, now this change is visible to any other method when you call again. Okay, for example, if you call the foo method again, next time it is 11, and then it will be 12. So let's call the foo method again. Between calls, the modified value is preserved. Next second time, when you call the foo method, it is 11, and you now increment it to 12. You can see this is second time it is 11. And not only foo method, if you have another method, so let's say I have a method called bar. Say G is, and say I say G equal G, or G plus C equal 10. So here I change it to increment it by 10 also. Let's run it. Now it will be initially 12, then okay. It is initially 12. Okay, let me run it again. So why it is 12? Then it must be 22, right? Okay, why it is not happening? Let me save everything. Start debug session, restart debug session, stop debug session. Maybe debug session is running. Okay, let me run it again. Now it must be 22. Okay, give me 1 minute. Why it is not picking that? Am I calling the bar method? Yes, I'm not calling the bar method. That is the issue. Bar. Okay. So I just wrote the method, but I forget to call it because otherwise the last output must be 22. 22. Now, if I access G from main method also, it is 22. Okay. G is G. Okay. From anywhere now, whatever the change a particular method has done to global variables will be visible to other methods. Okay. So that is how the global variables work. Okay. So global variables are variables declared inside, but whatever the variables you declared inside the method, each time you call that method, those are reinitialized. The values are not preserved. But global variables values are preserved and visible to all the methods. Right, so that's it about method. Any question? Any question you are having? So return value, parameters, okay. Local variables, of course, local variables, you can have same name in different methods. Then the global variables like this. So you can refer to global variables, you can change global variables. There's another tricky area, that is if you have a global variable and also local variable with same name, right? So here also X, here also X. Then so in your method, when you refer to X, actually you are referring to the local variable. So the moment you have a variable with the same name as a global variable, you don't see the global variable anymore. You are now working with the local variable. Okay, so therefore, whatever the change you do to X is not affecting your global variable. Okay. Best practice is don't do like that. Just use different name, but if you by any chance if you have a local variable with same name, then when you refer to that variable name, you are always referring to the local variable, not to the global variables. Okay, that is a tricky scenario. Usually examiners are interested in tricky scenarios. Okay. Right. So the final subtopic related to method. Actually, now we are done with methods. Okay. This is a small subtopic related to methods. So use of methods in clever way. That is called recursive method. Recursive method means your method you call itself. So earlier what we discussed is for method called bar method. So that is one method calling another method. That is not recursion. When that method returns, then this method returns. Recursion means a method calling itself. So then someone will ask, why do you want to call, why do a method want to call itself? First, I will show you what is mean by recursion. So let's say I have a Java class. So recursion demo. This is my starting point, PSVM. Okay, so let's say I have method static, say foo. This is not doing any meaningful thing. And say S out, say foo start, foo end, static void. And here I will call the foo method call itself. Now what will happen? It's like you have two mirrors and you look at your face. Right? So then you can see infinite number of images. So there's one image here, that image become object to this one, that image become object to this one, and infinite number of things. So this is also similar thing because your method calls, so we call foo method in my main method. Now what happens is the foo method calls itself. So therefore, this is a never-ending recursion. So method keep calling forever. So then your Java runtime environment JVM will detect that this is a never-ending never-ending recursion. So because it will take your resources, computer resources. Sometimes it can even struck your computer if it is keep happening. So it will terminate the program because this is a useless kind of a recursion. Okay. So anyway, let's start it. Don't worry. Your JVM will stop the program after some time. Okay. The output will be keep. You can see. So after thousands of calls, your JVM has detected that this is useless, never-ending recursion. So therefore, it has terminated. Okay, it has terminated because otherwise you are taking a lot of resources. Okay, you can even check your task manager. Sometimes you can see there's a heavy use of resources, and then JVM all of a sudden stop it. Okay, say I think heavy use of CPU or maybe heavy use of memory also. Okay, let's try it and see. Yeah, you don't feel it because it quickly detect it. Okay, quickly detect it. Maybe CPU, there will be a big burst all of a sudden. And you can see it goes up and coming down because it keep calling itself. Okay, right. Anyway, this is not a useful thing because this is a never-ending recursion. But there are some problems which are recursive in nature, right? Recursive in nature. So that means these problems can be break when we can break it into smaller problem. So then when we solve the smaller problem, effectively you solve the bigger problem. So those problems are called recursive problems, right? Recursive problem. Not every problem is recursive, but there are some places these problems can be solved in a recursive manner. And those are very, very interesting problems and useful solution mechanism is use of recursion, like searching, sorting. Those are some interesting uh, problems that you can use recursion to quickly solve it. Okay, right. So one such famous problem is finding factorial. So therefore, I'll explain how to do that. And then, of course, you can, by your own, think about few more problems that you can solve using recursion. Okay. So factorial is a mathematical concept. So by definition, this is how factorial is defined. By definition, factorial 0, this is how you use, what is the symbol we use. This is a mathematical concept. By definition, factorial 0 is 1. Factorial 1 is 1. Factorial 2 is 2 into 1. Factorial 3 is 3 into 2 into 1. Factorial 4 is 4 into 3 into 2 into 1. Of course, 2 into 1 is 2. 3 into 2 into 1 is 6. 4 into 3 into 2 into 1 is 24. And factorial 5 is 5 into 4 into 3 into 2 into 1. And that is how in maths the concept of factorial is defined. Just like 5 to the power 3 is 5 into 5 into 5. It's a definition, right? This is also definition, definition for a concept. So then someone will, why do you want to define like this? Because this calculation is heavily used in some part of the mathematics, like probability. There's a topic called, actually that part is in your semester 2 maths, counting, that is combination and permutation. Those who have done A-level maths, they have already done that. So this factorial is very useful to doing those, getting those results or calculations. Okay, so that is why we are interested in factorial. Of course, factorial is just one example of programmatically finding using recursion. Okay, but there are so many other problems you can solve. Right. So therefore, you can see that Factorial 0 is 1 by definition. Other factorial is, for example, factorial n is n into n minus 1 into n minus 2 into 1. So that is why factorial 4 is 4 into 3 into 2 into 1. And again, you can see that if you look at the pattern, factorial 4 is 4 into factorial 3. And factorial 3 is 3 into factorial 2 and so on. So therefore, factorial n is n into factorial n minus 1. So that is the recursive nature. If you want to find factorial n, that is n into factorial n minus 1. If you want to find factorial n minus 1, n minus 1 into factorial n minus 2 and so on. So therefore, this is a recursive problem. So maybe we can solve it using recursion. Okay. Calculating the factorial. Right. So let's create another class. I will call it factorial demo. Recursion demo. So let's have the main method PSVM. And let's create a method called factorial. Static factorial. You can give any name, okay? Say static, it returns an integer. Okay, so you must tell me what is your value, which factorial you want to find, 5 or 5, 6 or 10 or whatever. Say int x. Right. So what we do is, of course, you can solve this problem without recursion. That means using for loop, you can solve this problem very easily. For example, if you send 5, your answer must be 5 into 4 into 3 into 2 into 1. Okay, right. So can you solve this problem and return a value without recursion? That means don't call yourself. Don't call, that means your factorial method must not call the same method, but using loop, while loop or for loop or whatever loop, can you return me the value? So then when I call, say I will assign it to a variable, say int r factorial. For example, if it is factorial 3, your method must return 6, 3 into 2 into 1. If I send 4, your method must return 4 into 3 into 2 into 1. That is 24. Right? Can you write a logic for that? But don't use recursion. Just using loops, you can solve this problem, right? So we'll take a small break also. After the break, we'll do this. First of all, you must solve this problem using without recursion, using loops. Then I will show you how to solve this using recursion also. So then what we do is we do some past paper questions, because now we have done about 1/3 of your programming syllabus. But exam wise, half of the questions are from this 1/3. So remember, we have done the 1/3 of the syllabus. But your exam paper wise, half of the paper is from this 1/3, sometimes even more than half. Okay. So therefore, today we want to do some past paper questions, so that I want to take you to the exam mood for the programming subject. Okay. Right. But that is after finishing this recursion. But make sure you do this without recursion, implement this code. Okay. And maybe you can post it to the WhatsApp group. Okay. Your code. Right. So we'll take a small break. Now it is 3:15. We'll be starting at 3:30. Right. So let's write the code. Say I want the factorial. So for example, factorial 5 is 5 into 5 into 4 into 3 into 2 into 1 and so on. Okay. But first I will check whether your x is 0, because it's a special case, because factorial 0 is 1, right? If x x is greater than 0 only, I will do like this. Otherwise, right? Otherwise, I just return else. I can just return 1. Right? Return 1. So that means if it is 0, I will assume that you only send me the 0 and positive numbers. I am not doing any validations. Okay, if it is greater than 0, I will calculate the normal way. Otherwise, I will return 1 because factorial 0 is 1. Okay, right. So now this one, if your x is 5, I want to find 5 into 4 into 3 into 2 into 1. So therefore, I will use a for loop. Or even you can use while loop. Okay, so int I equal to x. I can start with x value. As long as my I is greater than or equal to 1, or I can greater than 0. I minus minus, I want to decrement. Okay. I will take a variable here, int r. I will initialize it to 1 because I want to multiply. So r equal or r multiply equal r equal r into, or I can simply say r multiply equal also. We did that operator last time. Multiply equal x, right? X. So x, sorry, I will be initially, if your x is 5, it will be 5. Next time it will be 4, it will be 3, it will be 2, it will be 1, and then it will be 0. 0 is not greater than 0, you get out of the for loop. Okay, get out of the for loop. And then at the end of the for loop, I will return R. You can have multiple R return statements. So if you come to else, you will return 1. Otherwise, you do this calculation and return it. Okay, calculation and return. Right, so I hope this logic is properly executed, but if there are bugs, we will fix it. Right, so it's out R. So the output must be 6 now. 6, 3 into 2 into 1 is 6, and see whether it's correct. If you have implemented it properly, I should get return 6 and print as 6. Yes, it is 6. So then what about if it is 4? 4 into 3 is 12, 12 into 2 is 24. So then it must be 24. Let's see. Yes. What about if it is 5? So then 24 into 5. 120, right? Of course, then it's working, right? Right. So I implemented it without using recursion because there's no rule saying always you must solve problems using recursion. And of course, every problem can't be solved using recursion. But this can be implemented without recursion like this. Okay, like this. So think about it. So that is why I gave you about 15 minutes for you to think. So think means think and code it. Like code it and test it and see whether your answer is correct. You don't need anyone to check whether your answer is correct. You can check it by yourself, right? Right. So this is the non-recursive solution. So therefore, I will just call it factorial non-recursive. Just okay. So of course, then my method call must also be factorial non-recursive. Okay. So now I will implement this using recursion. Recursion. Now we started in a very gentle manner, like writing hello world, but now we are in the serious stuff. So if you have not done your studies during the past few weeks, like four weeks, now it will be something like a Greek. That is your problem, right? So you should have studied your variables, operators in last weeks, right? You can't keep postponing things. And control structures also we did last week. So today we are using control structures. So for example, if you absent for control structures, so you never did those examples, but by coding, So now you are in deep trouble. You don't understand what I'm talking. So that is not my problem. That is your problem. Okay. Right. So now let's write recursive solution. Okay. Recursive solution. So I'll call this static int, let's say factorial recursive, just to make it, give it a different name. And again, I will give int parameter x or something like that. Okay. Yes, I will share the code at the end. Okay, the full code, not the only today's code, the all the codes. Okay, so far we have done. And so if I forget, just remind me again. Uh, Post a message to the group. Okay, so then I will remember. Right. So let's implement this recursively, because recursion can be sometimes really handy. For example, in semester 3, you have subject called data structures and algorithms. So there you learn different data structures like tree structure, stack structure, queue structure, uh, graph data structure. In some algorithms like searching algorithms, sorting algorithms, we heavily use recursion. Okay, so that is why you want to get the feeling of recursion. Okay, right. Uh, so let's do a recursive version. Right? So again, if x is 0, it's a special case. When you use recursion, don't just call it itself, because then it's a never-ending recursion. Always you call your method itself conditionally. So initially you call itself, after some time you don't call itself. Okay, right. So if my x is 0, I will return 1, because factorial 0 is 1 by definition. Else, now I'm calling it recursively, but conditionally. After some time, it will get into the if condition. Initially, it will be in else condition. For example, if it is 5, it is in the else. Okay. That's what I do is I will return x into I call this method itself, but this time I will be sending one less value, that is minus x, right? X into this. Again, I'm calling, then 5 into factorial 4, 4 into factorial 3. Factorial 3 is 3 into factorial 2. Factorial 2 is 2 into factorial 1. Factorial 1 is 1 into factorial 0. Of course, factorial 0 is 1. Now it is not recursion. Now we are getting the return. Okay. So it will take a little bit of time for you to familiar with these concepts. But always when you call yourself, your method itself, make sure you call it in if-else condition. Initially, you keep calling yourself, but after some time, you get into the non-recursive part, and that means you are returning. Okay, so the other thing is when you call recursively, this is what happens. So you call yourself, call yourself, call yourself, and after sometimes you don't call yourself. That means you are into the else part or if part. Now you are returning. Now you are returning like this. So these method calls are waiting for the other method call to return. So it start returning when you are not in the recursive part. Now it's return, and final answer is return. So that is what is my divide and conquer. So this big problem is solved by solving this problem. This problem is solved by solving this problem. This problem is solved by this problem, and so on. And then those results are accumulated to get the final result. Okay, it's an interesting concept. It's an interesting concept, but you need little bit of IQ, little bit of seriousness to understand this concept. Okay. Now I call the recursive version and see whether we get the same answer. So now I call factorial recursive. Okay, so we'll call this R1 and I must get the same results. Okay, I'll call this R2. Okay, So second one, this is factorial non-recursive. Anyway, I got 120. This is factorial recursive. I'm again sending 5. My expectation is again I should get 120. So that means my logic is correct. Okay, so let's run it and see. If there are bugs, let's fix it. Oh, so that means there's a bug. Why is that? Because it should not be 1, it should be 120. Okay, that means definitely there's a bug. Factorial recursive. If x is greater than 0, sorry, this is wrong. If x is 0, it must be 1. Otherwise, of course, when you say 5 is greater than 0, therefore you return 1. Recursion is not happen. So if x is equal to 0, return 1. Otherwise, that means you are sending 1, 2, 3, 4, and so on. So then you call it self. Okay, so there was a small mistake. That bug, I fix it. Okay, so if you send something like 5, this is 5 into factorial 4. Then again, you are calling itself 4 into factorial 3, 3 into factorial 2, 2 into factorial 1, 1 into factorial 0. 0 means you are returning 1. So that means now you can get the return statements. Okay. Right. So now it should be getting the correct answer, 120 for both cases, because I fixed that bug. You can see. And of course, if it is 4, it will be 24 and so on. So this is a recursively solving the factorial calculating factorial. And this is non-recursive. Without using recursion, you solve that problem using a for loop. So you can see that same problem, you can have multiple solutions. So what we do is we give you more and more options to you guys. So then maybe you can solve it using X approach, Y approach. So you have more and more resourceful. That is the purpose of this degree program, right? So at the end, you must be IT professional who can solve problems. Right? That's it. Who cares your BIT degree? I don't care whether you get A or A plus for programming. I don't care at all. Because I know plenty of students who get A for programming, but they can't develop a software. So that is attitude issues and so many issues. Right? So therefore, I'm a person who don't care about your results. Of course, I'm happy if you get A's. Okay, but it doesn't mean that I'm happy if you get fail. My sometimes you might feel like that. Okay, so what I'm telling is, if you don't pass the programming subject or whatever subject, I'm not happy about you. But just because you pass exam, I don't care about you as well, because there are some students they fail exams. They fail exams. That means something wrong with them. That means they have not understood the concept and so on. Some other students they pass exam, but they can't develop software. Right? They can't develop. They pass exam, but they can't solve practical problem in the society. Right? So other people they pass exams and also they can solve practical problems, software or whatever. So this is what we want. This is the මෙන්ගොල්ලෝ දැන් රත්තරන් කොල්ලෝ කෙල්ලෝ ටික. ඒගොල්ලෝ විභාගات පාස් වෙනවා, ජීවිතේ ජය ගන්නවා, ලෝකෙටත් වැඩක් කරනවා. ලෝකෙ තියෙන ප්‍රශ්න විසඳන්න පටන් ගන්නවා. software develop කරනවා. හරි. මේ ඇවිල්ලා ඉතින් කරන්න දෙයක් නැහැ. ඒගොල්ලන්ට ඔළුවට බීටර් වෙන්නේ නැත්නම් කරන්න දෙයක් නැහැ නේ වැඩි. හරි. මේක තමයි භයානකම සෙට් එක. විභාග හොඳට පාස් වෙනවා. වැඩක් කරන්න බෑ. අර කාලකන්ණි සෙට් එකක් ඉන්න රැකියා විරිද උපාධාරී පොල් බූරුව ටිකක්. හරි. කාලකන්ණි 70. හරි. විභාග පාස් වෙනවා වැඩක් කරගන්න බෑ. මේකට නම් වැටෙන්නේ මුන් තමයි මහා කාලකන්ණි 70. හරි. මෙන්න මේකට වැටෙන්නේ. හරි. විභාගات පාස් වෙනවා ඒව පාවිච්චි කරලා වැඩක් කරනවා. හරි. වැඩක් කරනවා. හරි. ඉතින් මේකට වැටෙන්න නැත් එපා. ඉතින් මේකට වැටෙනවා කියන්නේ ටිකක් මෝඩ පහය කියන එකනේ. මෝඩ වෙන්න ඕනේ නෑනේ. විභාගේ පාස් වෙන්නේ. හැබැයි so make sure you can do things practically. Okay, so somehow get into this. Everyone will love you, right? So you are a resource. සමාජයේ සම්පතක්. මේ තින් සමාජයේ තින්න කාලකන්ණි සෙට් එක. හරි? Right. So now you know how to solve factorial problem using recursion. non-recursive solution also you know. Okay. Right. So that's it about methods. Right. So now we have done one more topic from programming. Now we are into the object-oriented programming. Okay. Right. So now we'll do some past paper questions because one question we විභාග පාස් වෙන්න තෝනේ කියලා නැත්නම් හිතන්න ප්‍රෝග්‍රෑම් විභාග පාස් වෙන්න ඕනේ නැහැ කියලා. හරි. විභාග පාස් වෙන්න ඕන. හරි. මේ කොටට වැටෙන්න එපා. හරි. විභාග පාස් වෙන්න විභාග පාස් වෙන මදි. ප්‍රායෝගික ලෝකෙට ඇවිල්ලා ප්‍රශ්න විසඳන්න පුරුදු වෙන්න. පොතේ ඉඳලා මේ කාලගණනිය වෙන්න එපා. හරි. පොත විතරක් කියන්නේ විභාග ප්‍රශ්න පත්‍රයේට පොරවල්. සමාජයට ගියාම සාමාන්‍ය ලෝකෙට ගියාම අමු මැටි ගොඩවල් නේ. එහෙම වෙන්න එපා. මැටි ගොඩවල්නේ කපටිකම සමානලට තියෙන්නේ. ප්‍රායෝගිකව වැඩක් කරන්නේ නැහැ. රයිට් ඒගොල්ලෝ හිතන විභාගේ පාස් කරලා මේක ගෙදර ෆොටෝ එකක් ගහගත්තාම උපාධි සාතිකය ගත්තාම ඔක්කොම හරි කියලා. අනිත් මිනිසුන් අන්දගෙන ජීවත් වෙන්න පුළුවන් කියලා. එහෙම කරන්න බෑ. ඔයා වැඩි ඉගෙන ගන්න ඕනේ වැඩියෙන් මහන්සි වෙන්න. හරි? වඩා ඵලදායී වෙන්න. හරි? අනිත් අය 100ක් කරනකොට ඔයාට පුළුවන් වෙනවා 1000ක් කරන්න වැඩ. ඒකද අපි ඉගෙන ගන්න. අනිත් අය 100ක් කරනකොට 5ක් කළා කකුල් උඩ දාගෙන ඉන්න නෙමෙයි ඉගෙන ගන්න. උපාධි ගන්න. අනිත් අය 100ක් කරනකොට ඔයාට පුළුවන් වෙනවා 1000ක් වැඩ කරන්න. අන්න ඒකට අපි ඉගෙන ගන්න. හරි. අනිත් අයගෙන් යැපෙන්නේ නැතුව ජීවත් වෙන්න අපි ඉගෙන ගන්න. සමහරව ඉගෙන ගන්නෙම අනිත් අයගෙන් යැපෙන්නේ. හරි. එහෙම කරන්න එපා. It is right. So now let's do a past paper question. Okay, not past paper question, set of questions. So we'll straight away start with 2023 paper. Okay, 2023 paper. Because that is the latest paper. Because we can do at least half of the paper now. Half of the paper. Okay, I'm pretty sure about that. Two 2023 is the paper. You can get the past paper from Google, your University BLE also. What's this? Right. So let's do at least about 10 questions. This is the last year paper, the latest paper, right? Previous batch paper. 40 questions. You can see each question will have 5 choices with only one correct answer. So this paper is different. Only one answer means usually the paper is easy, right? But some papers you will say one or more answers are possible. That is where the negative marks are applied. So now here, if you give the correct answer, you get 1. If you give wrong answer or more than one answer, you get 0. This is like your A-level paper, right? This is like your A-level paper. Okay. So last year there was a student who got a lot of A's and C. Sorry, not C, C minus. Lot of A's. So the reason is that student has thought that this is multiple answers. So that guy has marked some other answers also. Okay. So therefore each and every paper you need to read individually. Right? Is it only one answer or multiple answers are right there? Okay. So just keep that in mind. Okay. Right. So multiple answers are possible. Right. So let's take one by one. Question number 1. Let me roughly check how many questions now you can do. 1, 2, 3 you can do. 4 you can do. 5 you can do. 6 you can do. 7 you can do, 8 you can do, 9 you can do, 10, 11, I told you more than half, right? 12, 13. So last time we did continue break. 14, 15, 16, 17 you can't do, 18 you can't do, 19 you can do, array, today we did, 20 you can't, right? So how many questions are there? 40. So almost 20 questions you can do, okay? Almost 20 questions. So let's do question number 1, right? Actually, I want you to give an attempt also, but I want to start it. Okay, so therefore we'll do only 10 questions because otherwise I am doing a unfair thing. Without you attempting me doing the paper is unfair. But I want you to put it into the, just like I want to push you to the swimming pool. So if you want to swim, you must put it jump into the swimming pool. So I'm just doing that. Okay. That is why I'm doing this before you. Maybe you guys have not attempted, but I don't care. I just want to do at least 10 questions with you. Right. Question number 1. Which of the following is correct regarding Java programming language? Right. Take 1 minute because I just want you to read and find the answer because it won't take more than 30 seconds. It derives its syntax from C language. Right. It is a platform-specific programming language. The output of Java compiler is an executable code. Java applet is small program that execute on server. So that we have not done it yet. But just remember this is wrong. So therefore I just make it easier because we have not done applet yet. D is wrong answer because applets are executed in the browsers, not servers. Characters of Java are inherited from Python programming language. I don't know what is mean by characters. That is to check whether your common sense. So you must have idea about is Java came before Python, Python came before Java. Are there any connection between Java and Python? So if you are an IT professional, you must have an idea about these things. So that is to check whether you have those kind of a understanding, right? Right. What is your answer? So D is not an answer that because we have not done applet. I just give you the hint. Anyone? What is your answer? Don't worry, your answer might be wrong, but at least give a try. If you are confident, you can just give me the answer, but don't look at the answer sheet. Right? So a lot of students say C.
Answer C.
Any other answer? Right? Some says no. Multiple answers are. Why do you give me multiple answers? The instruction set says only one answer is correct. So when the instruction set says only one answer is correct, why do you give me multiple answers? I read the instruction, okay? Right. So some students say C. It's a fuzzy question anyway. So examiner has deliberately put up a small, somewhat fuzzy question as question number 1. So therefore, even my answer might be wrong. That is fine. But let's give a reasonable attempt because the examiners try to add a little bit of fuzziness. I will eliminate the obviously wrong answers. Okay. It derives from syntax from C language is fairly okay. Actually, it derives from C++, then Java. But not really syntax from C, rather syntax from C++. But C++ came from C. So therefore, indirectly, yes. So therefore, this is maybe correct because C, C++, then Java. Okay, Java derived from C++, but C++ derived from C. So therefore, indirectly, this is correct. It is a platform-specific programming language that is definitely wrong because Java is platform independent. So if you eliminate obvious answer, that increases your probability. And D is obviously wrong answer. Once you learn Java applet, you will learn it. Java applet is a small program that it's not executing server. Applets are executed in the web browser. So therefore, that is also definitely wrong. The output of the Java compiler is an executable code. Actually, it is in a way, yes. That is why I told you this question is very fuzzy. But it is executable only if you have Java runtime environment. JRE. It is not a EXE actually. Some languages 100% executable. That is EXE. Like compiling C, you get EXE file. But when it comes to Java compiler, it is executable only if you have Java runtime environment. So therefore, this answer is again fuzzy. Okay, fuzzy. So it might be correct, thinking that okay, JRE is available, yes, it is executable. But if JRE is not available, this is not correct. Okay, so that is why I told you these are fuzzy. Right. So then E, characteristic of Java inherited from Python programming language. So that can't be the case because if I can remember correct, Python came little bit later than Java, or it's pretty much the same time. So therefore, I don't think that Java inherit anything from Python. Either Python came pretty much same time as Java or a little bit later than Java. So if I can remember correct, Java came a little bit earlier than Python. So therefore, I will not take that. So now I have two answers. It derives from syntax from C language. The output of the Java compiler is an executable code. So this is half truth actually. It's not executable, but if JRE is available, executable. And this is also half truth because it is not directly derived from C, but indirectly derived from C. Okay. So therefore, I'll go for A because I feel like A is more reasonable than C because it's not really executable, but in a way executable if you have the JRE. So therefore, anyway, I'm not 100% sure because the examiner has deliberately put up a fuzzy question to the question number 1 that sometimes examiners do. Anyway, I'll go for A. Maybe examiner might go for C also. Not C also, maybe rather than A, examiner may go for C. Okay. It's 50-50. Sometimes I feel like going for C because this is not direct. But while loop and all those things are pretty much C. Right? Variables, declarations, array declarations, pretty much like C. So therefore, anyway, I'll go for A. But there's about 50% chance the examiner might go for C also. But anyway, you can't do like that. You need to pick up answer. I'll pick A. Okay, I'll pick A. Let's see the answer. Yes, examiner has picked A. Maybe there's a star. Maybe examiner has given some second thoughts. Let's see why there's a star here. Consider either one of the given answers, either one option or other, not both. What is that? No, that star is for the question 21, okay? Not for the question 1. So that is, you can see sometimes for 2 answers also examiner has given marks, okay? Right. So therefore, anyway, examiner has taken A. So remember, why I did not take C is, when you compile, what you get is class file. Class file is not really executable file. It must be again interpreted by Java runtime environment. So that is why I told you it is a half truth. Okay. So therefore the answer is, the better answer is A. Okay. Better answer is A. Right. So let's move on to second question. Which of the following indicates that correct statements regarding top-down development process? Remember we discussed about top-down decomposition. Today also I mentioned that you break it into smaller part. Big problem, you break it into smaller part or modules. Maybe further subdivide if it is still complex. And if it is still complex, you can further subdivide. So that is called modular decomposition. Or we call it top-down decomposition. So the idea is divide and conquer. So then you can solve these smaller problems. When the smaller problems are solved, these problems are solved means this is solved. These problems are solved means this is solved. And these problems are solved means this is solved. Right. So now what is your answer? Anyone? What is your answer? Only one answer is correct, okay? Modular design is connected directly to top-down development. Okay. Modular design is connected to top-down development. Top-down means you develop a top part. Top-down means top-down development. Yes, top-down development means you first develop the top part, then develop the down part. But what we actually do is we develop the down parts, thereby effectively developing the top part. Because when you develop the down part, you are developing the next part. When you are integrating this part, you are developing this part. So therefore, it is not top-down development, bottom-up development. Actually, what we develop is these small parts. When we develop these small parts, effectively we are developing these parts. And when we further integrating, we are effectively, finally, we have developed the final product, the top product. So therefore, it is not top-down development, rather bottom-up development. Top-down decomposition to understand the problem. Designing is top-down. Development is bottom-up. Okay, development is bottom-up. So therefore, I will not take that. So therefore, I will not take that. Data-driven programming is based on structured top-down approach. Data-driven means your approach is driven by data. Okay. So you think about the data, what kind of processing you want to do, and so on. So anyway, I'm not very sure about that. Is it top-down or bottom-up? So let's keep it open. If nothing is there, I will take this, but otherwise I will not take this. But this is sort of a wrong answer for me, because you top-down design and development is bottom-up. It starts with low-level modules. Now they talk about the top-down development, right? This is the top-down development. Top-down development means top to down. Okay. It starts with low-level modules and progressively forms the high-level system. That is bottom-up. So low-level modules means this. And when we develop these low-level modules, we effectively develop the top modules. So therefore, this description is not for top-down development, rather bottom-up development. Testing and debugging are typically delayed until the entire system is implemented. No, that is not the case. Remember, I explained you the software development methods and software development tasks. So don't delay testing until the entire system is implemented. So that is why we have unit testing. So each unit test it, then integrate it and see whether the integrations are working. And gradually you are testing the system testing. So you come to system testing after unit testing, integration testing, and then only you do that. So when you develop this unit, you can do the unit testing. When you develop this unit, you can do the unit testing. Then when you integrate these two, you can do the integration testing. So finally, only you come to the system testing and user acceptance testing. So therefore, this is also wrong. Okay. So you don't delay your testing until the entire thing is done, because that is a very bad practice, dangerous practice. Detailed implementation of individual functions begins without considering the overall system design. So that means you think about the detailed implementation without considering the overall system design. So that is wrong, right? So remember, in the designing, first you look at the overall design, architecture, big picture. So once you design the big picture, then only you design the details. Then you design the details. So first you look at the big picture, architecture, then you gradually break it into components, subcomponents. That is designing. Designing is top-down. Development is bottom-up. So therefore, this says detailed implementation of individual functions begin without considering the overall system design. No. First you consider the overall design, because designing is top-down. Development is bottom-up. So therefore, this is wrong. So therefore, these answers are pretty much conflicting or wrong. So therefore, I will go for B. Okay. So I'm not 100% sure whether data-driven programming is really top-down, because data-driven programming is very rarely used approach. Usually, we just go for top-down decomposition and bottom-up development. Right? Usually, it's not data-driven; it's method or the procedure driven. Okay. So data driven means you 100% or more concentrating on data aspects. Like first you do the database designing and so on. Okay. But anyway, it says top-down approach. I'm not pretty sure about this, but anyway, these are pretty much wrong answers. So therefore, this is the one that remain. So therefore, I will go for this. Okay, I will go for this. Second one answer is A. Well, how is that? So examiner's answer is A. Let's see why. Modular design is connected directly to top-down development. Top-down development. How comes that? So modular design. Yes, we do designing top-down, but we develop bottom-up. So that is a debatable answer. I don't agree with the examiner's answer. Okay. Because modular design is not top-down development. It is top-down designing, and then you usually do bottom-up development. Okay. But anyway, examiner has taken A, so that is a debatable answer. That is a debatable answer. So let's keep it as an open question. I don't agree with that answer, but anyway, it doesn't matter. My opinion doesn't matter. So that can happen. Okay. So there can be that kind of questions here and there. Okay. So the examiner has taken that this is correct, but it looks like I don't agree with that. Maybe it is top-down design. Maybe then the examiner should have mentioned it's top-down design, not top-down development. Okay. But anyway, examiner's answer is A. Okay. Examiner's answer is A. I told you this is I'm not very sure, but then the examiner has taken that data-driven development is also not top-down. Maybe data-driven development is also bottom-up. But very rarely we go for data-driven development. That is the issue. Okay. Right, third one. Which of the following statement is are correct regarding type conversions? Remember in Java, bigger type to smaller type, you need to do explicit casting. A smaller type to bigger type, you can do implicit casting. Okay. Right. So let's see. But there's a small issue with this because you have not done wrapper classes. I think they are referring to wrapper classes also. But anyway, let's don't worry about that. Int can be assigned to byte by casting the target type to byte because int is bigger, right? Byte is smaller. So therefore, when you need to do explicit casting. Say you have byte variable like this, you have int variable like this, 100. Why? So then you have to say byte x. Otherwise, you will get a compiled. Why? Because byte is a small type. So when you go from bigger to smaller, you need to cast it explicitly. Okay. Casting the target type as byte, definitely yes. Right. So there are automatic conversions from numeric type to Boolean. No, right? Boolean is, there are some languages where 1 is considered true, 0 is considered false. But that is only some languages. But in Java, you can't assign something like 10 to Boolean variable. Boolean variable. You will get a compiler. So there's no automatic conversion in Java. Okay. If you have tried out, you may have got that error. Okay. I have not specifically tried out, but my common sense says Java doesn't allow this. Okay. Automatic type conversion will occur if the destination type is larger than the source type. Yes, if the destination type is a broader value, like int to long, automatic type conversion happen. Float to double, or int to float, automatic conversion. That is implicit casting. So that is correct. So I'll go for 1 and 3. And I'll go for 1 and 3 only. Okay. So let's see the answer. Is it D? Right. Examiner has given marks for D. That is my answer. And at the same time, the examiner has given mark for B also. B means 3 only. 3 only. I don't know why. Because this is correct. Int can be assigned to byte by casting type to byte. Maybe because this is capital I. That might be the only reason why examiner has given mark for 3 only also, because if it is, there's no data type called int with capital I. Other than that, of course, 1 is correct. 1 is correct. Anyway, examiner has given mark for D. Okay, mark for D. Right, fourth one. Anyway, answers are 1 and 3. Only thing is this int must be simple I, because there's no data type called int with capital I in Java. Okay, maybe that is why examiner has given marks for B only also, 3 only also. Okay, right, fourth one. Which of the following can be, now I told you that the idea is make you serious. You guys are serious. You think beyond others, right? You guys are not careless. You guys are not just stay in the surface. So that is what expected. That is the expectation, right? So think about these concepts in little bit hard manner. Okay, this is not A-level exam. This is not O-level exams or grade 5 scholarship exam. Okay, this is a degree level. So degree level is for serious people. So they only selected the best people for the universities, right? Best people, serious people with high set scores, right? Others are left alone. Okay, so that is why in level 1 exam they filter out non-serious people. I told you they filter out non-serious people. So that is why in level 1 the passing rate is less. Okay, so that means you are not very serious about. Because remember, when it comes to university degrees, those who are having 3 A's are also there, right? High set course. But this BIT degree program is open to anyone with 3S passes. It doesn't mean that having that 3S mindset, you can finish this degree, right? So maybe you have entered to this degree program with 3S passes, but you must develop into someone with the mindset of at least 3B passes during this period, because you are evaluated in the same level. You are evaluated in the same level. So be serious. Get into that. Of course, if you get into this BIT program with A's and B's, so you usually you are in that serious mindset. I'm referring to those who have just got maybe 1 C and 2 S passes. So get out of this S mentality. අපි කියන්නේ ගොඩ දා ගන්නවා කියලා. ඒ සමහර කියන්නේ සබ්ජෙක්ට් එකක් ගොඩ දා ගන්නවා කියලා. සබ්ජෙක්ට් ගොඩ දාන්න එපා. සබ්ජෙක්ට් ගොඩ දාන්න බෑ නේ යන්නේ වැලි ගොඩ දානවා වගේ වැඩකට. සබ්ජෙක්ට් ගොඩ දාන්න බෑ. සබ්ජෙක්ට් එක්සලන්ට් වෙන්න ඕන. එක්සෙල්. right? Super. හරි. ඔයා ටාගට් කරන්න 80ක් 90කට. නැතුව යන්තම් 40ක් දා ගන්නවා කියන්නේ මොන කාලකන්නිකම. ඒ කියන්නේ සබ්ජෙක්ට් ගොඩ දානවා කියන්නේ මේකද 40ක් දා ගන්න. නෑ 40ක් දාගෙන මදි ප්‍රොෆෙෂනල්ස්ලා, ડોක්ටර්ස්ලා, ඉන්ජිනියර්ස්ලා. ඔයගොල්ලෝ 90ක් දාන්න පුළුවන් වෙනවා. හරි. ඒගොල්ලන්ට තමයි මේ ලෝකේ තියෙන කම්ප්ලෙක්ස් ප්‍රොබ්ලම්ස් සෝල්ව් කරන්න පුළුවන්. Right. Which of the following can be valid identifier in Java? Remember, identifier means class name, method name, variable name. So we discussed some rules. So your identifier must start with underscore or alphabetical character. Numbers can be there afterwards. No other special characters other than underscore. Underscore විතරයි special characters වලින් allow කරන්නේ. එහෙනම් මොකද උත්තරේ? So there's a space here. Start with number. Hyphen is not allowed. Hyphen is allowed here, but ampersand is not allowed. Ampersand special character is not allowed. So here, start with character. Underscore is allowed. Underscore is allowed afterwards. So therefore, E is valid. All the others are wrong because here space, here start with number, here hyphen, here special character ampersand, but E is correct. E is valid. So we discussed that, I think, in the very first day when we do Java. Okay. Right. Fourth one answer must be E. Fifth one. If int A equal 2 and int B equal 3 are in Java program. Yes, int A equal 2, int B equal 3, both are valid. What would be the value of A and B and AOB respectively? We did operators last week. Okay, so this is bitwise and bitwise O. Like bitwise and then bitwise O. So let's do bitwise and 2 is 1 0. say byte. It's int anyway. Anyway, let's take it as byte 0, 0, 0, 0. Then 3 is 1, sorry, 1, 0, sorry, 1, 1. So 3 is 1, 1. 2 plus 1 is 3. 0, 0, 0, 0, 0, 0. Of course, all are 0. Right. So then when you do AND operation, 0 and 1 is 1, 1, sorry, 0 and 1 is 0, 1 and 1 is 1, others are 0. So that means 2. When you do AND operation, result must be 2 because this is base 10 2. What about O operation? 0 and 0, 1 is 1, 1, no 1 is 1. Of course, these are 0. So that is 3. So when you do O operation, it will be 3. When you do AND operation, it will be 2 because this is bitwise AND, bitwise O. So numeric values can be used for bitwise operation. The answer will be 2, 3. D. That is easy question. Okay. We did this kind of questions last week. Answer is D. Right. 6. Right. So this you can't do because still we have not done string handling. It's a string handling question. So therefore, let's keep it. Right. 7. We did the program designing using flowchart, NS diagrams, and so on. Okay. Match each flowchart symbol with the correct description. Right. That is a very easy question. Right. It's like piece of cake. So this is input or output. This is division. And this is start or end. Okay. Or maybe processing. No, processing is like this. Okay. Right. So let's see. Represent a decision point. Yes, like this. Represent an input to output process. So that is this. So now anyway, this is this. Represent the starting or stopping. Yes, start or stop. Because if it is a rectangle, processing. But there's a curve. So therefore, either it is start or end. So that is super easy question. 1B 2-way. 1B 2-way. Answer is D. Answer is D. Okay. 7th one, answer is D. Yes, answer is D. 8. I do the 8th one quickly. Which of the following statement is correct regarding repetition control structures? The do while loop is an example of a leading decision loop. The repeat until structure is a trailing decision loop. Now you must know your English also. What is leading? What is trailing? Leading කියන්නේ මොකද්ද? trailing කියන්නේ මොකද්ද? ඔයගොල්ලෝ දන්නවා මේ tractor එකේ තියෙන trail එකක්. හරි. දැන් දැනගන්න මොකද්ද trailing කියන්නේ කියලා. Counted repetition occurs when the exact number of loop iteration is known in advance. So that is not something directly mentioned in your notes or whatever. Maybe we need to use common sense. එහෙමති question දාන examiners ට. බලන්න මොකද්ද මේ counted repetition කියන්නේ? What is your answer? Counted කියන අපි repetition එක කලින් දන්නවා මෙච්චර වාරයක් කියලා. Counted. සමහර වෙලාවට repetition එක දන්නේ නැහැ. මෙච්චරයි කියලා. ඒ වෙලාව run time එකේ තමයි decide වෙන්නේ. For example, when we iterate an array, we know, right, from 0 to last element. So if there are 10 elements, it is 0 to 10. So that is a counted example. And we use for loop, right? I told you for this kind of situation, for loop is easier because we know exactly the situation. Right? What is your answer? Do while loop is an example of leading. Leading means at the beginning. Leaders like this, right? So decision is not at the leading, right? Do while is do while. This is where your decision at the end. So therefore, I will say no. I hope this is not a standard word. I use my common sense about English. Okay, so while loop is leading because the condition is at the beginning. So therefore, I'll say no. Repeat until. I told you repeat until is not used in Java, but some other languages use it. Repeat. We discussed that under pseudocode. Repeat. Okay. So then until condition. So when the condition is false, you again go there. When the condition is true, you get out. That is the difference between do while and repeat until. In do while, when the condition is true, you go there. Here, when the condition is false, you go there. When the condition is true, you go out. Here, when the condition is true, you go there. When the condition is false, go out. Here, when the condition is false, you go there. When the condition is true, you. That is what I say. Repeat until. Until. Past and repeated. Right? So therefore, it's sort of a trailing decision, right? At the end, check repeat until structure is a trailing decision loop. I hope trailing means at the end. Common sense. I just use common sense because this is not a standard word. So I'll say yes. Counted repetition occurs when the exact number of loop iteration is known in advance. Right. Again, counted repetition is not a standard word. But I feel like counted means you already know how many times it happens. Okay. That is my gut feeling. Okay. So it's a fuzzy word because examiners try to use different words and so on. Maybe for loop is good for that. Okay. Counted repetition occurs when the exact number of loop iterations is known in advance. Counted. Count means you just say x plus plus, that is counting. It's like 1, 2, 3, 4. But I'm not very sure about this, but it's not talking about the for loop also. But I'm pretty sure 2 is correct. So if anything is 1 is there, I will take it out. So I take it out. If 1 is there, I will take it out. Because I'm pretty sure 1 is not an answer if I understand my English correct. So now I have 2 answers. 2 only, 2, 3. Right. So 50-50 chance is there. Which one I should go? I'm not very sure about this word. Counted repetition. Counted. Counting means something like you count 1, 2, 3, 4. Okay. When the exact number of loop iteration is known in advance. So usually, if you know the exact number of iteration, usually this should be okay. I'm just going by my common sense now. This statement make little bit of sense for me, but this is not directly related to any specific loop control structure as well. Maybe general statement. I will take a little bit of risk and go for D. Because I feel like this is correct, but I'm not 100% sure because this is a general English statement. Okay. I'll go for D, but answer might be B also. Okay. But I'll go for D. Okay. I'll go for D. 8. Oh, answer is E. How comes E? So examiner has taken 3 as correct anyway. That is why E is correct. Examiner has taken 2 also correct. That means examiner has taken 1 also correct. So maybe this is just maybe a little bit different meaning is used. But this is lead trailing deletion is also correct, right? If this is trailing deletion, this must be also the trailing deletion. Because how comes repeat until is trailing and do while is trailing? Because both are checking the condition at the end, right? Okay, so let's ask ChatGPT because I'm not this terminology is not very standard terminology. It's very fuzzy terminology. This is not at all standard terminology. Okay, so let's ask maybe ChatGPT what is mean by leading decision loop because that is not a standard word we use. Maybe ChatGPT also don't know. But anyway, there's a higher chance. Let's ask what is mean by leading, what is the word the examiner use? Leading decision loop versus trailing. I think this is not a very standard knowledge. Maybe some mentioned in a particular book. Decision loop. Okay, let's ask ChatGPT because ChatGPT has access to millions of things. Right, so it says refer to the timing and responsiveness of the decision based on the information. A leading decision loop is protective and anticipatory. Decisions are made based on prediction, trends, and what is that? Shows in capitalize. I think this is not related to programming. Okay. Okay, let's say related to programming. I told you this is not a standard knowledge, right? In programming, in computer programming. I made it a little bit more specific question. Leading decision loop, also known as pre-test loop, condition is evaluated before the loop body. Yes, so our understanding is correct. Right? Before the body, condition is evaluated. But before the body, condition is evaluated. Okay. If the condition is false at the beginning, the loop body doesn't execute at all. So that is what happens in while loops and so on. Okay. The structure is typically found in while loop, right? You can see while and for loop. Okay. Because you check the condition at the beginning. Okay. So trailing decision loops do while. So because you check actually our understanding is correct. Okay. I told you trailing means usually you check the condition at the end. Right. So now the issue is examiner's answer is a little bit conflicting. So examiner thinks repeat until his trailing decision loop is correct. So then how come do while is a leading decision loop? Because if E is the answer, that is the examiner's answer anyway, do while must be a leading decision loop. So let's ask ChatGPT, is it correct or wrong? I feel wrong. Let's see whether ChatGPT agree with me or ChatGPT agree with the examiner. Okay. Let's straight away ask, is the do while loop an example of a leading decision loop? Right, loop, an example of, or we can say, is the do while loop a leading decision loop or trailing decision loop? I feel like this is a trailing decision loop, but the examiner thinks that this is a leading decision loop. That is why all the answers. Okay. I feel like it's a trailing decision loop. Anyway, let's see. You can see ChatGPT also says do while is a trailing decision loop. Okay. But the examiner's answer is E. E means all. All means examiner thinks one is correct. But ChatGPT also say do while is not a leading decision loop, but a trailing decision loop. So therefore, anyway, ChatGPT is also supporting me, not your examiner. Okay. So therefore, it's a debatable answer. It's a debatable answer. My answer is anyway 2 and 3. That is D, but examiner's answer is E. Examiner's answer is C. Okay. So that is definitely a debatable answer. Still, I feel like answer should be D, not T. Okay. Right. So now you must have a reasonable understanding about how the things are going. Right. What kind of questions are there, and there are sometimes even questions which are fussy. Sometimes the answers also we can't agree. So, right. So this one still we have not done much about the garbage collections and so on. But now you can continue because these are not that kind of fussy question. These are, if you know your programming, you should be able to do it. Right. If you know your programming, you should be able to do this. Right. Right. So we stop at this point. So I just wanted to give you some idea about the level of the expectations and so on. because otherwise sometimes students take it very easy. So they just wait 1 week before the exams and think that you can pass this. No, you can't do that. Okay, you can't do that. Maybe you can do that for information systems, right? But not for something like programming and so on. Okay, right. So we stop at this point, right?